In this video, I'm going to introduce to you guys the idea behind buoyancy. We're going to use few experiments to understand buoyancy. The very first experiment has the following setup. We have a mass, two masses actually, m1 and m2. Clearly m1 is more than m2, right? And also we need to make a note that m1 is attached to m2 with the help of a thread. And this two places, it just hung, it's not tied. Okay. In the second setup, we have an extra thing, that is a beaker, right? We have a beaker filled with water. So this is your tap water. So I would like you guys to pause and think over what will happen in both these cases. What might be the difference? All this thinking experiment or thinking exercise will help you guys. So please think over. Right? Let me show what is happening exactly, what will happen exactly. So what did we observe? In the first case, the object m1 fell faster than in the second case. Why is that? Let's understand this with the help of a free body diagram with respect to mass 1. So in case 1, there are two forces acting. The first obvious thing is the gravitational pull. Which is the second one? Second one is nothing but your pull by the thread, which in turn is getting that energy from m2 into g. Is it not? See, in both these cases, let me kind of in both these cases, the object is being pulled down. Because m1 into g is more than m2 into g, the setup will move in this direction. Agree? It will accelerate in this direction. So basically, let me actually do a better job. Basically, we are looking at something like this. Acceleration in case 1. In case 2, what is happening? Well, we do have the same pull down force. And also along with that, we do have a pull up, but we can see that acceleration is a lot lesser than in case 1. Why is that? What is happening over here? It's because m2 into g along with some other force, it's reducing the rate of fall. What is this force? That is nothing but your buoyant force. Okay guys, because of which the acceleration is less. So how can we conclude this? A better conclusion, a better way of concluding this would be F net in the first case, case 1, would be m1 into g minus m2 into g. And so your acceleration will be a lot less. In case of case 2, right, here it is m1 into g minus m2 into g. Along with that, we have a force, upward force, which is nothing but your buoyant force in this case. As a whole, the net force is less, and so the acceleration will be less. Agree? Right guys? So just keep this in mind. Let me conclude. Let us see all the experiment and then I'll conclude. Okay guys? Experiment 2. All we have here is a single mass attached, or it's being hung with the help of a weighing machine. The same thing is happening over here, but in this case we have the water. The object is kept inside the water. What is that we need to observe? We need to observe the reading. Can you see the reading? What is happening over here? This is 105 grams and this is 90 grams. Okay, so let me show this practically. Please observe this. right? What is happening over there? Let me explain with the help of free body diagram again. See, the object is not moving. Clearly, the upward pull and the downward pull has to be the same. Let me use different color. In both these cases, the forces have to be same. The up and the down, right? So upward force, let me not talk about upward force, let me talk about downward force. The downward force is your mass of the object into acceleration due to gravity. Mass of the object into acceleration due to gravity. But here, it is the weighing machine that is pulling it up. Here too, the weighing machine is pulling it up. But why is it showing less value? What does it mean? It should mean that there is some additional force that is helping the weighing machine. It's reducing the burden on the weighing machine. What is this extra force? It's nothing but your buoyant force. Is it not, guys? So let me explain it this way. We have F net over here to be 0. That is the net force acting on this is 0 because the acceleration is 0. It's not falling. What does that mean? mg minus Fw should be equal to 0. So mg should be equal to Fw. Or even better would be this is negative and this is positive. And so we have Fw is equal to mg. That is the weighing machine will exactly measure the weight that is exerted, that is experienced by this particular object, right? Here too F net is 0. That is very clear. So we have mg minus mg plus Fw plus Fb, which is equal to 0. But if I get an expression for Fw, it would be mg minus Fb, right? Clearly the weight, the force is the force that the weighing machine experiences in case 2 will be lesser compared to the case 1. So the weight experience in case 2 should be more than the weight experience in case 2, right? In case 1, the weight experienced by the weighing machine will be a lot more than, not lot, will be a bit more than with respect to case 1. Why is that? Because there is again an upward force that is because of the fluid. Agree? So to conclude, let me show this live. That is, with the help of this setup, we'll see a better action of buoyantic force as in when we pour some liquid into this container. So let me explain the setup first. See, I have a container. It has no water to begin with. This particular weight, the same weight, is attached to a spring balance. So spring balance helps measure the weight of a given object. How does it work? It has a spring and the spring is calibrated and all of that. So that you will understand in a year or two actually, not now. Okay. So what we have here is an empty container. To that I'll start filling with water. So I'll start filling this container with water. So you guys have to observe what happens. So please observe this, it's nice actually. So what started happening when we started pouring water? As in when we poured the water, the spring started moving up. How is that possible? The burden on the spring started reducing. Is it not? Only that makes sense. But who is reducing the burden? This burden is reduced by the buoyant force. Agree? So I hope you guys like this experiment. So to conclude, I want you guys to fill this two blank. In the first blank, we have to fill what? The buoyant force is an upward force. In the second one, it is, let's do this. Actually, there's some grammatical mistakes over here. Let me correct that off. So this it is experienced. Now it's better. The buoyant force is experienced by object when placed in a fluid. Agree? Please correct the grammar. I didn't read it properly while typing it. I made a mistake. So please correct this. It is experienced. What is experienced? The buoyant force is experienced by objects or object when placed inside a fluid. And again, a small note, air is a fluid. Remember that. Now, coming to definition, buoyancy force is an upward force experienced by a fluid, exerted by a fluid on an object immersed in it. Right? Agree? So that's your simple, straightforward definition. Okay, guys. So I would like you guys to at least write 1 or 2 experiments. Write the heading, write all of this explanation, free body diagram and all of that. Try to make a running note explaining what's happening. If not, you guys, this is much simpler. You guys can copy this along with everything, explanation and everything. Right, and yes, in this case, I would like you guys to write the conclusion and also the definition.